All right, so let's just zip through these. They're gonna go pretty quick, but I'd like you to really be plugged into this. I am taping it. I'll put the notes up. They'll be available. Practice test is up there. You can start it tomorrow if you want to, but let's kind of plan on doing this Monday and Tuesday. Okay. All right. So solve the equation. Now, one thing you got to do on these before I even launch into these are just screenshots of the actual problems. They're gonna look pretty familiar. Okay. This is there. I wrote their test on Moodle, so it's a lot of the questions are ones that are going to look like we've even maybe had a lot of these in class. Okay. Read the questions very carefully though, because there's not going to be. I don't have as much ability to go in and do partial credit on this because I kind of got to follow Blue Mountain's rules on this. You know, I'm going to treat this like even though it's not, I'm going to treat it just like a regular placement test. So when they say things like solve the equation, write exact simplified solutions. It means that we're writing the numbers down, right? We're just separating, thank you, we're just separating the solutions with commas like normal. So what would we do with this? Now it's been a while, this is Unit 2 stuff. Unit 2 is the most important unit that we do probably all year. We got to review it a little bit. With a quadratic equation like this, what's our strategy going to be? Take a second and think about it, and then somebody raise their hand and help me out. What do you think, Gabe?
Get the 6 out. Subtract 6.
I could subtract 6 and get it on this side instead of equal to 0. That's fine.
Isolate X.
Okay, but even we might end up undoing that because I can isolate x here. I can point to a single x, so therefore I can isolate x, can I? Right. That's my strategy is to isolate x. Right. So to isolate x,
you add 3, then divide by 3, then you square root.
very good. Okay, the steps are going to be I'm going to add 3, right? Then I'm going to divide by 3, and then I'm going to square root both sides. So in that order, if I add 3. I get 3x squared equals 9. I divide by 3. And I get x squared equals 3, right? And then if I square root both sides, what do I get? I get plus or minus. That's the thing you don't want to forget. I get plus or minus the square root of 3. So in Moodle, what I'm going to input here is a radical 3, comma, minus radical 3, right? No big deal, okay? All right, this is maybe one step up from that. Once again, can I point to a single x here?
Yes.
I can, so I'm going to isolate. But this time, what are the steps in order to isolate x? What do I have to do first?
Parentheses, the exponents.
So I got a square root to get rid of the square, right? Okay, square root both sides. Okay, so let's go through the steps. So you already told me I'm going to square root both sides to cancel the squared. So that's going to give me 5x plus 5 equals what?
9. No, plus or minus.
Plus or minus. Plus or minus.
I'm gonna miss like little simple things.
Yeah, don't forget the plus or minus. On the day of the test, I'm just going to put a big plus or minus on the board.
I didn't know.
You guys can look at it every time, okay? So we get plus or minus 9. Okay, what's next? Raise a hand, somebody. Help me out. Yes, ma'am.
Subtract 5.
Good. Subtract 5. Where do I put it?
In front of the plus or minus.
Ah, very good. Okay, so we end up with 5x equals. Okay, we good?
Yes.
Okay, this is a little too. I want a little more. Let's talk a little more thinking here, looking.
Divide
So
by
what's the
5.
last step?
Divide by 5.
Divide by 5. Okay. So if we divide each side by 5, we could split this up if we want to, but here's a good rule. A good rule is when you square root, if you get good numbers under the radical, so I get no i's and nothing left inside the square root, then you don't even have to split the fractions up. You can just keep everything in the top and get an answer for the plus, and then get an answer for the minus. To me, that's easier. You can always break it into separate fractions if you want to. But look how easy it is here now. I know this is, it's been a while, but we've said all these things. If I get negative 5 plus or minus the square root of 9, what if I take the plus sign? What's negative 5 plus 9? 4. So I get 4 over 5. There's one answer. If I take the minus, what's negative 5 minus 9? Negative 14 fifths. and neither of those can be reduced, right? So those are our answers, okay? So in Moodle,
That seems like we did that like 2 years ago.
it's been a while, hasn't it? So this is probably a good thing to do, don't you think? To
Yeah.
just kind of go back and hit this stuff before you leave. I mean, I feel pretty good about this late at the final way we're gonna leave. So real quick, now for a problem like this, it's an equation that we're solving, and so I have the option, I would check everything, because you only get one retake on this one, right? These are fractions, but all I would have to do with any kind of calculator, including a regular old just scientific calculator like you're gonna have, I could turn those into decimals and plug those in for x in this original equation and just see when I plug in those decimal values up here, do I get 81? And if I will. And if I do, then I know I got it right, okay? For the decimals, if I have to round them a little bit, I might get something like 80.94, who knows? But as long as I get something close to 81, then if I round decimals, I know I'm on the right track, right? That's just a good general strategy going into college and SATs and all that stuff too, okay? All right, what about this? It says, now read the directions, it says use factoring in the zero product property to, here's the important part, find all real zeros. Okay, so do you really have to use factoring in the zero product property? I mean, it's better to do it that way, but you can be independent, do whatever the heck you want. It just wants real zeros, right? Right? And I'm okay with that. As long as you can use the best technique for you to get the answers, I don't care how you do it. That's Blue Mountain. You can ignore what Blue Mountain says there. We're just going to do whatever's easiest. In this case, they're right, though. It would definitely be easier to, if I'm trying to find all the real zeros, that means I'm just setting the function equal to 0 and solving, right? Okay, so we get x squared minus 17x plus 70 equals 0. I'm going to solve that equation, and I would factor, wouldn't I? What are the magic numbers? There you go. X minus 7, x minus 10. So what are my solutions? So in Moodle, inside the answer box in Moodle, we have 7, 10, right? Okay. How about this? Same deal. I mean, you want to just skip this one?
Yeah.
Just factor. What would the magic numbers be? 7 and 8. So what would my solutions be?
-7.
-7 and -8. There you go. Good. Okay, now what about this one? This one, it says use factoring in the zero product property to find all the real zeros. Well, now is this one that we really would want to factor? Now let's look at this. You can. You could use bottoms up. But we talked about a general strategy being bottoms up is harder than the quadratic formula, so why do it? If you want to, that's fine. But we're trying to solve this equation. We want to find the zeros. So we're setting it equal to 0. And why not just use the quadratic formula, right? Can I divide each side by anything to make it easier? No, I'm stuck with it the way it is, right? So what is, warm up your singing voices real quick, what is the quadratic formula?
B squared minus 4AC divided by 2.
That's so nice. Okay, so then we'll just plug in our values of A, B, and C. So what's A? 10. What's B? What's C? Okay, so if I plug those in, we're just going to get x equals 7 plus or minus the square root of b squared. What's negative 7 squared?
49.
Minus 4 times 10 times negative 6. All divided by 2 times 10 is 20, right? Okay, so let's clean this up then. We got to figure out what we get underneath here, right? Okay, so I'm going to get, let's figure out what that number is. What's negative 4 times 10 times negative 6? Negative 4 times 10 is negative 40 times negative 6 is what?
240.
Positive 240. So I'm getting 49 plus 240 divided by 20. Well, that's 7 plus or minus the square root of 289. divided by 20. 289. Now, we could do that, we could make a factor tree out of that, but 289 happens to be a perfect square. It's 17 squared. Okay? So if you do, and I would always try that. If it's a number that you're unfamiliar with, a big number that you think might be a perfect square, possibly, first thing you would do is take a square root and see if it works, and it does. It does. It works out to be 17.
Is there a way to, simplify that on like the Desmos calculator, or is that you're gonna have to do the, branch thing?
But if you do the square root of 289 on
Well,
Desmos,
if it's not the perfect.
no, then you'd have to do the branching thing, and we can do the branching thing. If we did 289, but the thing is, with 289, you're gonna have to work pretty hard to find anything that goes into it, because 17 is prime. The only factors you're gonna get are 17 and 17. Okay. Tell you what I'll do on this one, though. Being as we're done with, I'll put up a list of, remind me to do this, the data test. I will put up a list of perfect squares all the way up through 20. Okay, so that'll be helpful too. I'll put them up on that board. Okay. So this gives us then, because that works out nicely, the square root plays nicely with us. We get nothing stuck in the square root. We get no i's. I can keep everything on the top. So let's look at what we get then if we take the plus. So if I take the plus, what do I get? What's 7 plus 17? 24? Okay, what divides into both 24 and 20? 4. So what do I get? There you go. So there's 1, 6/5, right? Okay. What if I take the minus? If I take the minus, I get 7 minus 17, what's that? Negative 10, right? What's that? Okay? Good? So those are my two solutions. Okay. Oh, is that the same one we just did?
Yeah.
Wow.
Yes.
That's weird.
Let's do it again.
Now we're over to that. Okay, how about this one?
Add one.
Completely factor the
Well,
polynomial.
Just add it. and
12i
then-
plus
Okay, you guys are making the mistake I told you
Wait,
not
no,
to
because
make.
you need to
Okay,
answer.
raise hands, please. Yeah, input? Yes, Aaron, what do you think?
Oh, yeah, I want the answer or the?
Well, what are we trying to do here?
Factor.
Trying to factor it, good. So what are we gonna do? Tell me out.
Oh, I don't know how to explain how to, I don't know how to explain the steps, I just know the answer.
What's the answer gonna be?
X minus 12 times X plus 1.
Good, okay. So now somebody fill in the blanks. So Aaron gave us the correct answer, which is,
You add the square root, you add 144.
No.
It's because we're trying to find two solutions.
okay, so if I'm trying to factor a two-term polynomial, it's gonna be difference of squares, isn't it? Because there's nothing I can undistribute. I can't factor out a greatest common factor. So the only way to deal with this would be to write this using the pattern. If we can, we want to write this using the pattern a squared minus b squared, which we can do. I get x squared minus 12 squared, right? And so what's my pattern? A squared minus b squared is just a minus b times a plus b. Doesn't matter, either order. Doesn't make any difference, right? So we just get x plus 12 times x minus 12. Okay? So you can see a difference of squares one. But that's really, we've done that, right? We've done a lot of that stuff, so you're in good shape on that. Okay, how about this? This is super easy. They did all the hard work. They already factored it for you. So if you get something that factors into a product of these two factors and it wants you to find the solutions, what's the only step left to do here?
Solve for x,
Meaning I'm just gonna,
isolate it?
well, no.
Combine language.
No, hold on. See, they did something, like, look, we've done this already today. If we go back, look what we did, like right there. Like, we started with a function, and then we did the hard work of factoring it. But once I get a factored equation in standard form,
Oh, you're just gonna take the negative part, or the?
Yeah, just-
both of them equal to 0.
right, which is, I'm just going to use the zero product property, right? That's all that is, right? No, we're trying to use the zero product property, which means I'm just gonna set the factors equal to 0, right? So all I've got to do is set this guy equal to 0. What are the 2 steps to solve for x? Subtract 7, divide by 6, so I get x equal, that's bad x. Can't live with that x.
How come they tweaked out like that?
I don't know. So there's one solution. Or if I take the other one and set it equal to 0, that's supposed to be orange.
Really rude, Pen.
I know.
It's tired too.
So I subtract 7 and divide by 2, right? And I get x equals negative 7/2. So those are my 2 solutions. Okay? Easy. They already factored it for you. Just set the factors equal to 0 and solve. Okay? Okay, so this time we're solving the equation. We're going to write exact simplified solutions, but we have to include i's in this case if we have any. But I don't think we ever get into this stuff. So there might, I don't know, maybe at the very end, but I don't think so. I don't think you ever get any i's. Oh yeah. So what do we do then? We want to try to find magic numbers. Do magic numbers exist that multiply to positive 48 and add to negative 14? Okay, now let's make sure we're playing the sign game. If they multiply to a positive, right, and add to a negative, they're both negative, good, and the numbers are 6 and 8. Very good. So then what are the solutions?
8, 6, and 8.
And of course in Moodle, what that's going to look like,
6 on 8.
you got it.
Cubes, bro.
Okay. How about this one?
This is the one that they don't want you to solve, or else the government will come to your house.
Yeah, that's true, but we're going to solve it
Yes, this-
anyway, because we're not afraid of them.
No, this is the one that we pick up on the
Right.
bus, and the janitor comes in and solves it, and then he gets
Get off
the
my
award.
car.
There we go. Okay. Okay, here we go. So what do we do? Very simple. What's the only step we got to do here?
Square root.
Square root. So we get x equals,
Square root of 80.
About,
But don't you pyramid it?
Don't we have to
go back.
do this?
okay, you're right. Raise hands, please. I got lots of good info, but it's too much. Pyramid it. Okay, but there's something else really important we're forgetting. Plus or minus.
Oh, God dang
Well,
it! We're all gonna miss that on the test, because I'm not gonna remember that. Unless you actually be the big plus and minus.
Okay, so Gabe's right. Just pyramid it. What are factors of 80?
420.
4 and 20.
Big one.
It's the weed numbers.
Big
It's
one.
the weed numbers. 5, 2, 4, and 5.
Okay, but now let's be smart about this. 5 and 4, very good. If we've already got a 4 up there, let's see if we can get another 4 out of it, right? Get a couple of 4s. So we get a couple of 4s, single 5, right? So then our answer is just going to be plus or minus 4 times the square root of 5.
Wait,
So question.
it's not exactly that, but when you're doing that triangle thing, I forgot. Like, if you have 2 singles, do you multiply them? Like, if they are the same, do you multiply them?
Yes. No, 2 couples you mean, right?
Like.
Oh, no, 2 single, you're right, you
Yeah,
multiply,
okay,
yeah,
yeah.
you're right, you're right. Or if you get multiple couples, then you multiply, if I had a couple of 4s and a couple of 3s, I'd have a 12 outside,
Oh.
right? Yeah.
But when you do 4 times that, or just 4 times?
No, you just do, when couples go out, so if I have a couple of 4s, then that means a 4 goes out front.
Okay.
So if I had a couple of 4s and a couple of 3s, I would have a 4 out front and a 3 out front, which would make it 12, right? And your question was, what if I have a single 5 and a single 7? Then inside I'd have a 35. Okay, you're right. So then in Moodle, this would just look like 4 radical 5 minus 4 radical 5, right? Okay, next. Factor the expression completely. This is an absolute low-hanging fruit problem, super easy. Don't make it hard. Don't make it hard. What do we do?
You just factor it.
That's it, right? So if I get a 2-term polynomial, I'm always going to see if I can factor out any polynomial. I want to see if I can factor out a greatest common factor, but that's the only thing I can do here, because this is certainly not going to fit any of our patterns. I'm about to kill myself here.
No, because it's addition.
Oh, yeah, you won't carry something. You're not lifting a hot tub.
So we get x times the quantity.
Nobody gets
Right.
Nobody gets that.
Yeah.
That's it.
Point that out, that's a
Right.
good one.
I get two, it's not working.
What? I
We
mean,
good?
You can't exactly like factor.
Okay, how about this one?
Isolate the X.
Isolate the x, good. Piece of cake, right? We isolate the x. Okay, hey, listen. Seriously, I mean, this is, I love seventh period, but I want us to kind of rein things in here so I want to get through this because this is important for you guys. The final is the last test that's this is gonna hopefully make you, but I do not want it to break you, right? So let's make sure it's not hard, but I want to make sure everybody gets fair access to a good review. Yes,
Is there practice for this on
there's a practice test up on Moodle.
Alright.
So you gotta go to the practice assessment section, it's the one at the very top.
Okay.
Okay? All right, so, what are the steps to isolate x?
You're gonna add
X
6, then you're gonna divide by 2 and then square it.
So 32, good, I divide by 2.
Yeah, then when you do the square root, you're gonna wanna put a plus and minus.
There you go. So what do I get then? Plus or minus? 4. So in Moodle, I'm just gonna get 4, negative 4, very good. This is no big deal, is it? Okay, now here's something you might have forgotten about, because we haven't completed the square in a long time. We really don't complete the square very much, but it's one of those Algebra 2 things that we're expected to know how to do, right? So when we're completing the square, if we've got x squared minus 12x, we know that we want to turn this into a single factor that's squared, right? There's two blanks we got to fill in here. We got to fill in what goes there, and then down in this part, we want to know what goes there. Okay, remember how we did this?
Divide
Well,
by 2.
Okay, so we divide the coefficient of x, b. We divide b by 2, and then what do I do to it? Square it. Good. So b over 2 equals negative 6, right? And negative 6 squared
36.
is 36. Okay? So this question is asking, you have a question, Lynn? Yeah, go. So this question is asking, what is c? What is the number that we're trying to fill in to create a perfect square trinomial, right?
We won't use like.
Okay, now you're gonna get two questions like this, so look at this one very carefully, because they look similar, they look really similar, you gotta read these things carefully. So this answer is 36. Okay, the next question you're gonna get though is gonna ask you, what would I get when I actually end up factoring this thing? And what number would go there? It's gonna be a minus 6, because half of negative 12, so I should make that orange. So it's a minus 6, right? What goes there is just half of b. Okay? So the answer to this question is 36, but this question is different. This question is asking, written as the square of a single factor, what is this equal to? So we want to write x squared plus 12x plus something as something squared, and this is the answer we're looking for. Okay, so what goes here?
36.
36.
Wouldn't it be negative because the last one?
No, it's the last one. Yeah, the last one was negative because right.
Because this one's positive 12x.
Right. So in this case, the last one we had a negative 12 divided by 2 was a negative 6. So what are we going to get here?
X plus 6.
X plus 6. Right? Because half of 12, b over 2 equals 6. So that's what we're adding to x.
Why don't you square it?
Well, we did here, but that's not what we're wanting. What we want here is we want to write this whole thing as a single square, right? As something squared. And if you think about it, why did we even pick the 36? We picked the 36 because it goes with the 12. Find magic numbers that multiply to 36 and add to 12. What are they?
6 plus 6.
6 and 6. X plus 6 times x plus 6 times x plus 6. You get the idea? And then back here on this last example, what two numbers multiply to positive 36 and add to negative 12? x minus 6 and x minus 6 squared, right? Okay. So maybe go through those two, especially on the practice test, right? Those are ones we haven't done in a while, so get a little extra practice on those. Okay, how about this? Solve the equation, write exact solutions, include i's if necessary. Clearly, how are we going to solve this one? Quadratic formula, you got it. Because I can't divide both sides by anything, we're kind of stuck with, you know, we got what we got there, whether we liked it or not, right? What's A, B, and C this time? A is 6, B is negative 17, C is, okay, so then if we do quadratic formula, x equals negative B, so 17 plus or minus square root. Negative 17 squared, that's that 289.
Oh, yeah. Yeah. That's what we call the business callback.
Yes, you're right. Minus 4 times 6 times, okay, all divided by
2a.
Okay, so let's focus real quick. Let's just focus on this part right here. Maybe. So we get, how about if we do, what's the easiest way to do this? How about if we did 6 times 7 is 42, and then multiplying by 4 is just doubling and redoubling. So 42 doubled is 84 doubled is
164.
168.
I was so close. See how good I did?
So we get the square root of 289 minus 168. Well, that's just 121, isn't it? Right?
Uh-oh.
Okay, so we get 121 in the radical. So then we end up with 17 plus or minus the square root of 121, all divided by 12. What's the square root of 121? 11. 11.
It's gonna one.
Okay, and so this is one where we don't have to split the fractions up because we just got a whole number out of our square root. So if we take the plus sign, 28 over 12.
Can we do an example?
So, say it
Can
again.
you show us one, an example of when we don't get a whole number, like how we do it, how we like divide it by like, let's say it was like 2 square root 11, how would we do that by 12? Like, just to make it like use like square root 11.
So yeah, right, what you would do is we would just make it 17 12
Yeah.
plus or minus like 2 radical 7 over 12 or
Do we have
something.
to simplify that?
Well, then the 2 over the 12 we could reduce.
Okay, we'll do one.
Right, yeah, just reduce what you can. But the main thing is we split it into separate fractions, so it's easy. Okay, so what does that reduce to?
7/6.
Very good. 4 goes into 28 7 times, 12 3 times. If we take the minus sign, 17 minus 11 is 6. 6 twelfths is what?
Skylar, 6.
Yeah,
One and a half.
1/2.
One
There you go. Oh, so there's my 2 solutions, 1/2 and 7/3. Okay? You might get your wish right here. Okay, so what about this one? Solve the equation, write exact solutions. Okay, this looks like one where it's not gonna, we're gonna probably end up getting something under the radical like that. We'll see. Okay, so what are A, B, and C on this one? Clearly this is not gonna factor, is it? No magic numbers exist. We can't isolate x, so this is a quadratic formula problem. A is, B is 4, oh, whoops, B is negative 4, C is,
-7.
so x equals, what? You tell me. 4 plus or minus root, negative 7
No, 16.
16 minus,
Negative 1.
4 times 1.
4 times 1 times negative 7, right?
Then divided by
Divided by what?
4 times 2.
Okay, good. So then what's under the radical? Let's focus on this part. So under the radical, we're going to get 16 minus 4 times minus 7 is what? 28.
we just pretend like it's negative so we can try that out of the way?
Well, this is gonna be, we're gonna get something just about as bad. We're gonna get a radical that doesn't simplify completely. So 16 and 28 is what?
40.
49,
No.
48,
42.
45.
44.
44.
I was right the first time. I was like, am I dumb?
Oh, I didn't hear it.
Oh,
I didn't hear it.
yeah. That's okay.
Okay, so 44, would you agree that square root of 44 is not, that's not a perfect square? So we're gonna get stuck with a radical, so let's go ahead and split this up.
4 and 11.
So we're gonna get 4 over 2 plus or minus, yeah, what's that gonna break up to?
4 and 11. So it would be 2.
There you go, 4 and 11, 4 breaks up into 2 and 2, so I'm gonna get a couple of 2's and a single 11, right? So we're gonna end up with, the square root of 44 on the top is gonna become a 2 radical 11 divided by 2. So how can I simplify that fraction?
Just make it a lot. Big square.
Square root of 11. 2 over 2 simplifies, 1 over 1. And so we end up with x equals 2, no whistling please, I'm recording this, 2 plus or minus square root of 11, right? So in Moodle, how would I enter that?
2 plus the square root of 11, comma 2 minus square root of 11.
There you go, right? Okay. All right, so discriminant stuff, okay? Once again, it's been a while, right? You know, but we talk about the discriminant like in calculus. We just did some problems the other day where we used that quite a bit. This is useful information, but you will be. You will be. I think you will. I bet you will someday. I believe you will.
Someday.
Yeah,
Someday.
someday starts next week.
So, okay, so the discriminant.
Isn't that?
You do. You're right. I'm gonna wait for everybody else. You're on top of it.
Wait, what?
That's good.
Elaborate.
So the discriminant is, it's the part in the quadratic formula that sits inside the radical, right? Because remember, the discriminant is what discriminates between the imaginary and the real zeros, right? This is what tells us what we're gonna get. So if we start off with our quadratic formula, this is the part, that's the discriminant, right?
Yes.
So we know that if under the radical we get a negative number, then that's giving us two imaginary zeros, right? They always come in pairs, right? So we just have to figure out what we're getting. If the discriminant, if b squared minus 4ac is less than 0, we're getting 2 imaginary, right? If b squared minus 4ac is greater than 0, then I'm getting 2 real solutions, right? One for the plus and one for the minus, remember? Get 2 real solutions. Now, what about the weird case, the in-between case, where,
Isn't it where it equals
Are we
0?
gonna have to remember?
well, having you remember this is really not
One solution.
one, you're right, I get 1 because
Oh, and if it's equal to 0, then it has to be.
0, yeah, the plus and the minus are the same answer, aren't they? Plus 0 and minus 0 gives me the same thing, so I only end up getting 1 real solution, right? So all we got to do is just figure out, we don't have to do any of the hard stuff in the quadratic formula. We just have to figure out, is b squared minus 4ac positive, 0, or negative? I don't even really care what its value is. I just got to know which one of those 3 things is it, right? So if we calculate b squared minus 4ac, what is that going to give me? 4 minus 4 times 1 times, what's that equal to? It's 0. Okay, so that tells me then, based upon the above, the above equation has how many? 1 real. Okay, and so I think actually what that meant was,
Is it imaginary or?
I'm going to pull that one up because I don't know. Let's see what's behind I want to know what's behind the screens.
Has
Aren't you curious now?
Number one.
Would it be positive, negative, or zero?
Oh, yeah.
I think so, yeah. Let's see. So here's your choices. Discriminant has a 0 value, which means it has 1 real. Okay?
So for the other one, you put like less than 1?
So your choices are going to be positive, negative, 0. Okay? And for this one, so I'll write those down. So your choices are positive, negative, and 0.
That's the dog's name from Nightmare Before Christmas.
0 is the answer. And so that means down here,
Has 1 real
it has 1 real.
I just saw him today.
Okay?
Tyrese.
All right.
I didn't see theirs.
Okay, how about this? Super easy. Hey, so don't get off track, please. We're getting there. We get 2 more in, and we're done for the day. That's pretty good. We get through 17, 18. We only have 7 tomorrow. That's a pretty good day for Friday.
That is good.
So if we're adding up complex numbers, very, very simple. What's the answer?
Like, how we solve this, or what?
7. You're right. 17, right?
Combine like.
Because we're combining like terms.
Yeah.
We treat the i's like variables, right? So I'm going to get 3 plus 14, and then I get negative 12i plus 12i, so the answer is just 17.
Yep.
Everybody see that?
Yeah.
Okay. How about this one? What if I multiply?
Or multiple, oops.
Don't you make it square? Isn't it just the same thing as x?
No.
So it's almost the same thing as x. We treat the I like a variable. So let's start with that. We're going to distribute like normal. When I distribute the 7, I'm going to, so I'm FOILing, right? So I distribute the 7 and I get negative 42 plus 7i, right? And then I'll distribute the 13i. 13i times negative 6 is minus 78i, right? But then here's the one you got to be careful with. 13i times I is plus 13i squared. What is I squared equal to?
Oh, it's
What is it?
1.
Negative 1. There you go. So, when you multiply out complex numbers, when you get the I squared, all you have to do is it's just going to change the sign of that term. So we end up with negative 42 plus 7i minus 78i minus 13. If we combine like terms, we got to finish. Negative 42 and negative 13 is 5. Good. 7i minus 78i.
Oh, that's a 6, that's a 7.
There it is. All right.
Yeah.